When discussing electrical taps using number 12 wire, it's essential to understand how the total number of taps is determined and how it relates to both grounded and ungrounded conductors. The figure of 14 taps using number 12 wire indicates a configuration with 7 ungrounded taps and 7 grounded taps, resulting in a total of 14 taps. This means that for every ungrounded conductor tapped, there is a corresponding grounded conductor tapped, maintaining a balanced circuit. Consider a 20 amp circuit as an example. According to relevant electrical handbooks, the typical configuration allows for more taps than a 15 amp circuit due to the higher amperage capacity. In this case, the handbook example indicates 16 taps, with 8 ungrounded and 8 grounded conductors tapped off the main circuit. This configuration is designed to safely distribute power to multiple devices or locations while adhering to electrical code requirements. It's crucial to adhere to the National Electrical Code, or NEC, guidelines when installing or modifying electrical circuits. These codes specify the maximum number of taps allowed based on the amperage of the circuit and the size of the tap conductors. Exceeding these limits can lead to overheating, voltage drop, and potential fire hazards. Number 12 wire is commonly used for 20 amp circuits, but it is essential to verify the ampacity of the wire and the circuit breaker to ensure they are compatible. The ampacity of a wire is its current carrying capacity, and it must be sufficient to handle the load of the circuit. In addition to the number of taps, it is also important to consider the length of the tap conductors. The NEC specifies maximum tap lengths to prevent excessive voltage drop and ensure the proper operation of electrical equipment. Generally, the tap conductors should be as short as possible and never exceed the length specified in the code. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause lights to dim, motors to run inefficiently, and other electrical equipment to malfunction. To minimize voltage drop, it is important to use the correct size of wire for the circuit and to keep the conductors as short as possible. When making electrical taps, it is crucial to use approved methods and materials. This includes using properly sized connectors and ensuring that all connections are tight and secure. Loose connections can cause arcing, which can lead to overheating and fire hazards. There are several different types of connectors available for making electrical taps, including wire nuts, crimp connectors, and insulation displacement connectors, or IDCs. Wire nuts are a common type of connector that are used to join two or more wires together. Crimp connectors are used to create a permanent connection between two wires by crimping them together. IDCs are used to make taps without cutting or stripping the existing wires. When choosing a connector, it is important to select one that is rated for the size of the wire and the amperage of the circuit. It is also important to follow the manufacturer's instructions for installing the connector. In summary, when working with electrical taps using number 12 wire, it is important to understand the number of taps allowed, the length of the tap conductors, and the proper methods and materials for making the connections. By following these guidelines, you can ensure the safety and reliability of your electrical system. Always consult the latest edition of the NEC and any local electrical codes to ensure compliance. Firstly, ensure the circuit breaker or fuse protecting the circuit is properly sized for number 12 wire, which is typically 20 amps. Secondly, the total number of taps, including both grounded and ungrounded conductors, must not exceed the limits specified in the NEC for the specific circuit and conductor size. Thirdly, the length of the tap conductor should be minimized to reduce voltage drop and ensure efficient power distribution. Fourthly, use only approved connectors and methods for making electrical taps, ensuring secure and reliable connections. Fifthly, when calculating the total load on the circuit, include the amperage of all devices and equipment connected to the taps. Sixthly, avoid overloading the circuit, as this can cause the circuit breaker to trip or the fuse to blow. Seventhly, properly ground all electrical equipment connected to the taps to prevent electrical shock hazards. Eighthly, regularly inspect the electrical system for any signs of damage or wear, and replace any damaged components promptly. Ninthly, if you are not comfortable working with electricity, consult a qualified electrician for assistance. Tenthly, remember safety is paramount when working with electrical systems. Always energize the circuit before making any connections or modifications. Consider the implications of voltage drop in your tap design. Voltage drop occurs when the voltage at the end of a conductor is lower than the voltage at the source. This can be caused by the resistance of the conductor and the current flowing through it. Excessive voltage drop can cause lights to dim, motors to run inefficiently, and other electrical equipment to malfunction. To minimize voltage drop, use conductors that are large enough to carry the current without excessive resistance. Also, keep the conductors as short as possible and avoid long runs of small gauge wire. The NEC provides guidelines for calculating voltage drop and specifies the maximum allowable voltage drop for different types of circuits. Ensure that your tap design complies with these guidelines. Consider the environmental conditions in which the taps will be installed. If the taps will be exposed to moisture, corrosive fumes, or extreme temperatures, use conductors and connectors that are rated for these conditions. Also, protect the taps from physical damage by installing them in a suitable enclosure or raceway. The NEC specifies the types of enclosures and raceways that are required for different types of installations. Ensure that your tap design complies with these requirements. It is important to understand the difference between grounded and ungrounded conductors. Grounded conductors, also known as neutral conductors, are connected to the earth and provide a return path for current. Ungrounded conductors, also known as hot conductors, carry the electrical current from the source to the load. It is important to connect the grounded and ungrounded conductors correctly to ensure the proper operation of the circuit and to prevent electrical shock hazards. The NEC specifies the color codes for grounded and ungrounded conductors. Typically, grounded conductors are white or gray, and ungrounded conductors are black, red, or blue. Always follow these color codes when wiring electrical circuits. Consider the type of load that will be connected to the taps. Different types of loads require different types of wiring and protection. For example, motor loads require overcurrent protection that is sized differently than overcurrent protection for lighting loads. Also, some loads may require special wiring methods to prevent electromagnetic interference, or EMI. The NEC provides guidelines for wiring different types of loads. Ensure that your tap design complies with these guidelines. Always use the correct tools and equipment when working with electricity. This includes using insulated screwdrivers, pliers, and wire strippers. Also, use a voltage tester to verify that the circuit is de-energized before making any connections or modifications. Never work on live electrical circuits. It is also important to wear appropriate personal protective equipment, or PPE, when working with electricity. This includes wearing safety glasses, gloves, and appropriate clothing. Avoid wearing jewelry or other metallic items that could conduct electricity. If you are unsure about any aspect of electrical wiring, consult a qualified electrician for assistance. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent accidents. The NEC is a complex and comprehensive document, and it is important to stay up to date on the latest changes and revisions. The NEC is revised every 3 years, and it is important to use the latest edition of the code. You can purchase a copy of the NEC from the National Fire Protection Association, or NFPA. You can also find information about the NEC on the NFPA website. Remember that local electrical codes may be more restrictive than the NEC. Always check with your local building department to determine the specific requirements for your area. Following safe practices and adhering to the NEC ensures that your electrical installations are safe and reliable. Always double-check your work and test the circuit after making any connections or modifications. Proper planning and execution are key to success in electrical work. When calculating the allowable number of taps on a circuit, consider not only the NEC guidelines but also the practical limitations of the wiring configuration. Overcrowding conductors and junction boxes can lead to overheating and difficulty in making secure connections. It's often better to use a slightly larger junction box or to reduce the number of taps to ensure a safe and reliable installation. Proper labeling of circuits and taps is essential for future maintenance and troubleshooting. Use a permanent markable label maker to clearly identify each circuit and tap. This will make it easier to identify the correct circuit when making repairs or modifications. Also, keep a record of the wiring configuration, including the location of all taps and the devices connected to them. This information can be invaluable when troubleshooting electrical problems. Regular inspections of electrical systems are important for identifying potential problems before they become serious. Look for signs of damage, such as frayed wires, cracked insulation, or loose connections. Also, check for signs of overheating, such as discoloration or melting of components. If you find any problems, correct them promptly to prevent electrical hazards. Consider the use of arc fault circuit interrupters, or size and ground fault circuit interrupters, or GFCIs, for additional protection against electrical hazards. ICIs protect against arc faults, which are a common cause of electrical fires. GFCIs protect against ground faults, which can cause electrical shock. The NEC requires ICIs and GFCIs in certain locations, such as bedrooms and bathrooms. However, it is often a good idea to install them in other locations as well, especially in areas where there is a risk of moisture or water exposure. When working with existing electrical systems, be aware of the potential for asbestos or other hazardous materials. Asbestos was commonly used in electrical wiring and insulation before the 1980s. If you suspect that asbestos is present, do not disturb it. Contact a qualified asbestos abatement contractor to remove the material safely. Also, be aware of the potential for lead paint in older buildings. Lead paint can be hazardous if it is ingested or inhaled. If you are working in an area where lead paint is present, take precautions to prevent exposure. Consider the use of energy-efficient lighting and appliances to reduce energy consumption and save money. LED lighting is much more energy efficient than incandescent lighting, and it lasts much longer. Also, look for appliances that are Energy Star certified. Energy Star appliances use less energy than standard appliances. There are many resources available to help you learn more about electrical wiring and safety. The NFPA website is a good source of information about the NEC. Also, many community colleges and trade schools offer courses in electrical wiring. If you are serious about learning about electrical wiring, consider enrolling in one of these courses. Electrical codes and standards are constantly evolving to improve safety and efficiency. Stay informed about the latest changes and updates to ensure that your electrical work is compliant and up to date. Subscribe to industry publications, attend seminars, and participate in continuing education programs to stay ahead of the curve. When designing electrical systems, consider the future needs of the building or facility. Plan for future expansion by providing adequate capacity and wiring infrastructure. This will save time and money in the long run by avoiding the need for costly upgrades or modifications later on. Proper grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Bonding connects all metallic parts of the electrical system together to create a low impedance path for fault current. Follow the NEC guidelines for grounding and bonding to ensure a safe and reliable electrical system. Electrical systems should be inspected and tested periodically to ensure that they are operating properly. Use a qualified electrician to perform these inspections and tests. Regular maintenance can help to prevent electrical problems and extend the life of the electrical system. Power quality is an important consideration for sensitive electronic equipment. Power quality problems such as voltage sags, surges, and harmonics can damage electronic equipment and cause it to malfunction. Use power quality monitoring equipment to identify and correct power quality problems. Transient voltage surge suppressors, or TVSS, can protect electronic equipment from voltage surges caused by lightning or other events. Install TVSS devices at the service entrance and at individual equipment locations to provide comprehensive surge protection. Harmonics are distortions of the sinusoidal waveform of alternating current. Harmonics can cause overheating of electrical equipment and can interfere with the operation of electronic equipment. Use harmonic filters to reduce harmonic distortion. Electromagnetic interference, or ME, is unwanted electromagnetic energy that can interfere with the operation of electronic equipment. EMI can be caused by a variety of sources, such as radio transmitters, computers, and electrical equipment. Use shielded cables and enclosures to reduce EMI. In conclusion, understanding the nuances of electrical tap rules, conductor sizing, and safety practices is paramount for any electrical installation. By diligently following the NEC guidelines, employing proper techniques, and staying informed about the latest advancements in electrical technology, you can ensure the safety, reliability, and efficiency of your electrical systems. Always prioritize safety and consult with qualified professionals when necessary to mitigate risks and achieve optimal results. Always remember to disconnect all power sources before working on any electrical components. Verify that the circuit is de-energized using a reliable voltage tester before touching any wires or connections. When handling electrical tools and equipment, ensure that they are properly insulated and in good working condition. Avoid using tools with damaged cords or frayed insulation. Work in a well-lit and dry environment to minimize the risk of accidents. Keep the work area clear of clutter and obstructions to prevent tripping hazards. Use appropriate personal protective equipment, such as safety glasses, gloves, and insulated footwear, to protect yourself from electrical hazards. Never work alone on electrical projects. Have someone nearby who can assist you in case of an emergency. Before starting any electrical work, carefully plan the project and identify any potential hazards. Consult with a qualified electrician if you are unsure about any aspect of the project. Follow all applicable electrical codes and regulations. Local codes may vary, so it is important to check with your local building department to ensure compliance. Properly label all electrical circuits and components to facilitate future maintenance and troubleshooting. Use a permanent marker or label maker to clearly identify each circuit and its corresponding breaker or fuse. Keep a record of all electrical work that you perform, including wiring diagrams, component specifications, and inspection dates. This information can be invaluable for future reference. Regularly inspect electrical systems for signs of wear and tear, such as frayed wires, cracked insulation, and loose connections. Address any problems promptly to prevent electrical hazards. When making electrical connections, ensure that they are tight and secure. Loose connections can cause arcing, which can lead to overheating and fire. Use appropriate connectors and crimping tools to ensure reliable connections. Avoid overloading electrical circuits. Overloading can cause the circuit breaker to trip or the fuse to blow, which can be inconvenient and potentially dangerous. Distribute electrical loads evenly across multiple circuits to prevent overloading. Be aware of the potential for electrical shock. Electrical shock can be fatal, so it is important to take all necessary precautions to prevent it. Avoid touching exposed wires or terminals. Always use insulated tools and equipment. If you experience an electrical shock, seek medical attention immediately. Educate yourself about electrical safety. There are many resources available to help you learn about electrical safety, such as books, websites, and training courses. Take the time to educate yourself about electrical safety to protect yourself and others from electrical hazards. When selecting electrical equipment, choose products that are certified by a recognized testing laboratory, such as Underwriters Laboratories, or Canadian Standards Association, or CSA. Certified products have been tested to meet safety standards and are more likely to be safe and reliable. Install ground fault circuit interrupters, or GFCIs, in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor areas. GFCIs protect against electrical shock by detecting ground faults and immediately interrupting the circuit. Use arc fault circuit interrupters, or SIs, to protect against electrical fires. SIs detect arc faults, which are a common cause of electrical fires, and immediately interrupt the circuit. Consider the use of surge protectors to protect electronic equipment from voltage surges. Voltage surges can damage or destroy electronic equipment, so it is important to protect them with surge protectors. Install smoke detectors in every room of your home. Smoke detectors provide early warning of a fire, giving you time to escape. Test smoke detectors regularly to ensure that they are working properly. Have a fire extinguisher readily available in case of a fire. Know how to use the fire extinguisher properly. Develop a fire escape plan and practice it regularly. Make sure everyone in your family knows what to do in case of a fire. Store flammable materials safely. Keep flammable materials away from heat sources and open flames. Dispose of flammable materials properly. Never smoke in bed or while drowsy. Be careful when using candles. Never leave candles unattended. Turn off electrical appliances when you are not using them. Unplug electrical appliances when you are not using them for an extended period of time. Have your electrical system inspected by a qualified electrician periodically. Regular inspections can help to identify potential problems and prevent electrical hazard. If you are unsure about any aspect of electrical safety, consult a qualified electrician. Electrical work can be dangerous, so it is important to take all necessary precautions to prevent accidents.